So my last video stopped recording partway through, unfortunately. So in the interest of saving my own time, I now have everything that I was going to write as part of the video already written out, and I'm just going to kind of go over it the way I did in the part that didn't get recorded. So here's part 2 of spectral types. So as I was saying, anti-jump cannon rearranged the existing hydrogen alpha-based classification system based on temperature instead. And she came up with the system we use today, O, B, A, F, G, K, M. This is a temperature spectrum where O-type stars are the hottest and the bluest, and M-type stars are the coolest and reddest, and all the rest sort of exist on this spectrum. Now, anti-jump cannon thought that this was good, but she wanted a more specific system than just saying, oh, this star is A-type. So she also came up with the system of putting a number after the letter to further specify noun from 0 to 9. So instead of just saying, oh, that's an F-type star, you could say, oh, that's an F0, or an F5, or an F8. And these are arranged in order, right, like between the letters. So F0 is the hottest type of F-star, and F8 is one of the cooler types of F-star. But there's another, so that's what anti-jump cannon came up with. But there's another element to the spectral type classification system that I believe anti-jump cannon did not come up with, someone else did, called the luminosity class. Now, luminosity class roughly just means like how luminous is the star, how much light is it giving off. But that's kind of an oversimplification. You may have heard of things called like red giants or something, types of stars like that. Red giants are, from like a mechanical, their fundamental mechanisms for how they work are very different from normal stars, which we call main sequence stars. They're actually main sequence stars that are in the process of dying. So on the inside, they're very different, but they're very luminous, right? And, well, okay, I'm getting a little ahead of myself. However, even though they're very different from normal stars, both they and normal stars fit into this spectral type classification system. Red giants would be maybe K-type, right? But you definitely want to be able to distinguish between a K-type star that's just a small, normal, living main sequence star, and a star that's K-type because it's a red giant. And so that's where luminosity class comes in. Luminosity class is also indicated with a number, but this is a Roman numeral number, so it doesn't get confused with the Arabic numeral numbers that anti-jump cannon used. Type luminosity class 1 are supergiants, class 2 are what are called bright giants, class 3 are giants, class 4 are subgiants, and class 5 are what I've been calling normal stars, or main sequence stars. So, how do you put this all together? You may be wondering what spectral type our Sun is. Well, our Sun is a G25 type star. So it's of the G spectral type. The 2 means it's on the warmer, the hotter end of G, because originally the number after it meant like how many tenths, right? Like 2 would mean that it's, anti-jump cannon thought that it was roughly 2/10 of the way between G and K. So the 2 means it's definitely on the hotter end of G stars, and the 5 means that it's a normal main sequence star. So that's how kind of the whole spectral type thing comes together. So I believe that about covers spectral type. In the next video, I'll be discussing the assignment for this week, clearing up some possible misconceptions and giving some instructions that are helpful for doing it. So see you then.